Now we're going to take a look at simple random samples. This is the best type of sample, but hardest to do. So basically, we take a random sample from the entire known population. Each sample of size n has to be equally likely, it has to have an equally likely chance of being picked. What does that mean? It doesn't mean each person has an equally likely chance of being picked, although that should occur. What it means is if I'm picking 50 people, all right, and I decide to get from males and females, I'm not going to say, okay, I flip a coin, I'm going to take 50 females. If I get heads and 50 males if I get tails. I should also be able to have combinations of males and females as if I was randomly doing the whole population. So again, you want to randomize. And it does provide a representative sample, meaning, when done well, it provides a more precise estimate of population parameters. So this is what we prefer to do. One of the easiest ways is the hat method. You put the entire population in a hat. Mix well. Don't leave that out. Tell them that you're going to mix it, and then randomly pick without replacement. So if you pick Janie as one of your people, you don't put her name back in the hat. Another way you can do it is use a random number generator, and you could assign a unique number to each individual, meaning there's no repetition. And then use something impersonal to randomly select from those numbers. Now, another way we could do it, for example, at Cedar Ridge, all our students already have a unique ID number. So we would just use a random number generator to pick their ID numbers, knowing that I think there's 6 digits. Now, you'd have to say, what are you going to do if you pick the same student twice? Which could happen, not likely, but it could. So when you're saying this on your plan, you need to say, okay, no repetition. I'm not going to use the same kid twice. Also, since not all the 6-digit numbers are taken, you would have to write down what would you do if you draw an ID that is not assigned to someone. So you would just say, I'd skip it. Also be careful about using the word distinct number. We need to say unique, all right? Because distinct doesn't necessarily imply unique. You can do the same thing with a random number table, same as a random number generator. So you could say, okay, I'm going to take six digits off the random number table, and that's my student ID. If it's not available, we'll skip it. And if I've already gotten it, I will skip it then too. So bring up both those situations. So in our high-rise example, Anthony could take a list of 600 apartments, and they're numbered 101 to 120, 201 to 220, and then he could like put them all in a card or something and put them in a hat and randomly select them. Or maybe you could say, okay, I'm just going to number the apartments from 1 up to the 600 and assign them just kind of in order of number, and use a random number generator or random number table to pick them. So, and then if you did that, since there's 600 apartments, let's say you use 3 digits, you could do the digits 000 to 599. That would be 600 apartments. If you decide to do 1 to 600, you can do that, but you better tell me what to do with the 000 and what do I do with 601 and up to 999. We would skip those. So this method does have a good chance of producing a representative cross-section of opinion.